Hello, and welcome back to the Argyle AI Solutions Expo. My name is Naya with Argyle, and it's great to have everyone joining us today. A couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsor's virtual booth at any time during today's event. Our partner is committed to providing you with valuable content and great overall experience. At any time during today's event, you can visit their virtual booth from the main agenda page, which includes complimentary materials and information. To ask questions throughout the session, please simply type into the chat and we will address your questions at the end of the session. Also, be sure to subscribe to Argyle on YouTube for exclusive access to our past events. Now, without any further delay, I would like to introduce our speaker, Francois Martel, Field CTO at Newbird AI. We're excited to have Francois with us for a thought leadership and demo titled From Alert to Answer AI-Driven Root Cause Analysis for On-Premises Infrastructure. Welcome, Francois, and over to you.
Thank you for the introduction. I'm very excited to present to you today on the topic of AI SREs doing root cause analysis for on-premise systems. So basically, a lot of agents are running in the cloud. Cloud providers are providing their own. We have an agent. A lot of competitors are in the market. But what makes Newbird unique, amongst other things, is that we can work with your on-premise systems. So we have a lot of customers that are interested in using AI to solve on-prem problems. So today we're actually going to show you a demo with a Terraform managed ERP stack running on premise on vSphere and how Hawkeye, our AI SRE, can perform root cause analysis and help triage and resolve the issue with the on-premise system. So the on-premise RCA problem is more challenging than in the cloud, in part because the systems are, very siloed. You have siloed data. There's multiple layers of observability tools that are in place. There's no cloud API that provides the visibility into configuration. And you have a lot of tribal knowledge. Some of it, are people leaving the company that had that knowledge and are taking it out the door. There's poor documentation, and the systems have just been built over a very long period of time. And then there's a lot of alerts, which is also something that we see in the cloud, but on-premise systems have a lot of alerts. You have a lot of dashboards showing you a lot of information, but it's very overwhelming, and it's hard to get to the right alerts with the right information to resolve them. So the key, of course, to doing AI for root cause analysis and triage using IT alerts as the initial context is this context engineering. So at Newbird, we find that our solution does really well with root cause analysis out of the box because of this differentiated context engineering that we offer. So in the case of cloud, we automatically will start doing investigations using your observability data, your domain knowledge, and your infrastructure state. In the cloud, we can actually query that state using cloud APIs. What's really challenging on premise is that there is very difficult to have a very good view of the state like you have in the cloud. So what we're doing with our customers that have on-prem systems is using MCP servers. MCP stands for Model Context Protocol, and it's a way to provide context to LLMs. And so Hawkeye can be configured to consume an MCP server, and that MCP server that we're going to show today gives visibility into the Terraform state. But that could also be an Ansible inventory, a vCenter API, Kubernetes manifests, although we actually natively talk to Kubernetes as well. We have a plugin for that. And so the infrastructure state that we're going to show in the demo is going to be Terraform, and Hawkeye can actually use this information because a lot of issues are actually caused by misconfiguration. So the implementation we chose was very simple. That you can actually use Terraform MCP servers off the shelf from IBM, but we had a simple MCP server that we built to just search the content of your repository. So if you're doing GitOps with infrastructure as code, you can easily build MCP servers. And we have customers building more sophisticated MCP servers that get a lot of configuration information. So maybe they're watching files, they're doing some scans of information and then surfacing that through an MCP server to complete the picture. So the scenario we're going to demonstrate today is a root cause analysis of a problem that was introduced during a maintenance window where a Terraform was applied and changed the primary database for our ERP system running on VMs in VMware from 64 gigabytes to 8 gigabytes, right? So a problem was introduced, wasn't caught in time in the pipeline and got deployed, and that created a Postgres SQL memory issue, of course, right? So you have a primary that has 64 gigabytes and a secondary that only has 8 gigabytes. So queries spill to disk, latency cascades through the ERP stack, and the alert that you get usually is not pointing at the source of the problem, of course. It's basically a performance issue or a stability issue that's manifested in the ERP solution. So we have, a complex system with Hikari pool timeouts manifesting on the API server. We've got, batch jobs and reports that are seeing huge error rates. So when a problem occurs, this is common. You're seeing a lot of symptoms all over the place. You have all these alerts, and then the inevitable thing happens. You set up a bridge and you bring in 20 people from five different teams to address this big issue. And it takes hours of all these people's time to get to the bottom of it. And so if you look at this particular system, there's a lot of layers. So you can imagine there's a gateway, there's a team responsible for this gateway. There's a edge server, HA proxy that's managed by another team. So all these subsystems have teams managing them. They might even have each team on a different logging platform, a different observability tool. And so it's very difficult. And in this case, the color might not be very visible, but you see some green boxes and some affected boxes. So they're a little different shade here, right? So there's some services, many of them that were affected, but some not affected. So all these people have to get together to figure out what is the root cause. And these, events, cascade and develop over time. So here you have a full kind of timeline of what happened. And what we're going to see is that Hawkeye is going to automate the AI investigation, is going to take the events coming in and triage them. It's going to query your logs, telemetry, metrics, traces. It's going to look at the infrastructure state using the MCP server, and it's going to perform the root cause identification. And so it will save a tremendous amount of time. So you see here 7 minutes, 30 seconds. You have all the information you need to basically know what to do versus 2 hours of 20 people's time. And so the savings are tremendous. And so let us go right into a demo, and I'm going to show you how Hawkeye performed this analysis, and I'll give you a bit of a tour of the Hawkeye tool. So this is the home dashboard for Hawkeye. In here, you can see at a glance all your different incidents and alerts and the investigations performed, as well as the time savings through the past, 7 days, 14 days, 30 days. And you can filter, you'll see the noise reduction metrics, the time saved, the investigation and incidents, and then you can navigate here to filter even further based on the criticality of the incident. And you see at a glance the systems that were impacted, and you can get the quick view to go through the service map, see what's going on. You see some worker nodes were impacted, etc. Now let's go see an actual. Sorry. Uh, We're gonna have to edit this part also. I had all this set up. So let's go see an actual investigation. And this is the investigation that we were introducing earlier with the ERP system. So once you go to the dashboard, you see the triage information, but then you might want to go dive deeper. And to dive deeper into an incident, you come to this incident session where you have the full root cause analysis. And the structure of the root cause analysis can be controlled through instructions. But the default behavior is to show the summary, the description of the incident, the key artifacts, the timeline of events, the evidence, the root cause, which here is identifying exactly what the root cause is, this 8 gigabytes of RAM instead of the required 64 gigabytes. And then the corrective action, which here gives you the actual HCL, which is the Terraform language to fix the problem. And so the team has an identified source of the problem and a fix available. Now they can get to work and perform the fix, deploy it, and resolve the issue. And so this is basically a tremendous amount of time saved by Hawkeye. And this estimate is, I think, on the low end. We try to estimate the time savings, um, but you can imagine that a problem like this would waste a lot of people's time. So there's two key values that we offer: reducing the mean time to resolution, which, if there's a business impact to this downtime, can be very significant. In the Fortune 2000, the impact of downtime or service degradation is counted in the thousands of dollars per minute. And then the other benefit is all those 20 people being more productive. And so as you see on the RCA, this example is great because the RCA provide us the smoking gun, right? But sometimes the AI will provide triage information, and the SREs will need to get involved and ask follow-up questions. So down here, you see Hawkeye can actually recommend follow-up questions, and those could be sent in, and the investigation can be further developed based on these instructions. The other thing that SREs like to do is find out exactly how Hawkeye arrived at this conclusion. And so this is where the runbook findings comes in. So the runbook is basically a dynamically generated set of steps that the LLMs are going to use in order to answer the original question. So the original question is to investigate these symptoms that were identified with the ERP outage. And then the steps are basically going to be a set of queries to data sources. So you can see here the generic data source. This is our MCP server that's providing the list of resources, and the get resource is, these are tools in MCP. So Model Context Protocol exposes a set of tools to the AI, and Hawkeye can consume those tools and decide which tool should be used and to get the right information. We're also looking, in this case, at our logs in Grafana Loki, our metrics in Prometheus Mimir, and our traces in Grafana Tempo. These could be different systems, right? We support Datadog, Dynatrace, New Relic, all the major telemetry observability platforms. And so this is how Hawkeye performs its work. It picks the right information to go look at and uses that information in very highly accurate manner. So there's no hallucination here. All this data that you're seeing is coming from these data sources. So we have a very deep, visibility into everything that's happened. And Hawkeye really goes much further than your typical kind of AI copilot that would help you look at logs. It really does a deep analysis. It kind of analyzes the structure of the application. It builds up context over time. It learns that context and then creates these very rich investigation plans to get to the bottom of any issue. And so this scenario here was investigated with no prior knowledge. You can just plug and play Hawkeye into your environment, give it access to the information, and it'll know how to use this information to very quickly produce the data that you need to take action, to triage, to remediate, to document the failure for a postmortem with an RCA, and then finally to actually fix the problem long term, right? So somebody's got to go and reconfigure this Terraform script. But in the short term, we maybe somebody just went into vSphere and changed the setting from 8 gigs to 64. Okay, so that's how Hawkeye helps. Back to our presentation, we analyze our results, right? And so here you see the analysis of the Hawkeye investigation versus what we knew when we created this scenario, right? So we had a very controlled environment where we can verify what Hawkeye came up with is actually accurate. So 100% accuracy in this case. The root cause was matched, right? We identified exactly the root cause. We identified the service that originated the incident. We identify how the incident cascaded from the primary DB to the ERP API server to the reporting batch Redis front end and to the load balancer. So we can trace the whole impact of the original kind of incident or the original problem. We showed the evidence and we also came up with the corrective actions. So these corrective actions, I'm summarizing them here. You saw in the investigation demo. It's basically to fix the Terraform, apply infrastructure change, restart the VM, uh, monitor your VM sizing, right? So a lot of our customers are actually using Hawkeye to improve their observability. So we'll always make recommendations on how they can improve their overall reliability by tweaking how their alerts are configured, how their monitoring systems are configured, et cetera. And then we're also made a recommendation here to have a better change management review, of course. This would have prevented the problem. In the end, we estimate that Hawkeye saved 93% of the time that a human would have taken. And this is, in my opinion, kind of not like an hour and 10 minutes could have been much worse. And this 93% of the time saved really has a huge business impact. And it's an hour of time saved across multiple people. And so with Hawkeye, you can now manage with the same team a lot more of alerts and incidents in your environment. And this is what we're hearing from our customers and the people we speak to in the industry. They all want to use AI coding assistants to build more software. And if you're going to have AI for your developers, you really need to have AI for your SREs and operations folks. And this applies for on-premise as well as cloud customers. So the thing that I want to close on today is really for on-premise customers. A lot of them are still on-premise because of their security concerns. And so we have the leading solution not only for doing on-premise investigations, but also doing such a great job with securing that data. So we have a couple of models that our customers love. First of all, we are always going to be read-only. We're going to have the ability to query the data, but we're not writing any data. We have zero data storage. So all the queries are very surgical. The data is processed outside of the LLM before being passed to the LLM. So a minimal amount of information is sent back to the LLMs. And the data path can be fully controlled by the customer. So in our SaaS model, we have SOC 2 compliance for our SaaS solution, and we deploy an agent in the customer environment, which is a very lightweight component that keeps all the data on-prem and allows us to do a reverse proxy where Hawkeye can query the data through this secure connection to this on-prem agent. We also support running completely in the customer VPC. So if you have an Amazon or Azure um, footprint and your hybrid cloud, we're able to deploy in your tenant, in your VPC, where you leverage your network, your AI resources end to end. And so for enterprise customers, this is a big win. So beyond this demo, what I want to highlight is, we support these very complex environments. Most customers these days are not in a single cloud. They're not always, they're never 100% in one place. You have on-premise system, you have a cloud presence, you may have multiple cloud presences across AWS, Azure, GCP. The vendors in the cloud and the incumbents have solutions, but you as a customer, you have different plans, right? You're not going to lock yourself into one observability vendor, one cloud provider. And so you need a AI agent that can work with everything that you have. We work with any monitoring stack, any management, incident management system. So PagerDuty, ServiceNow, of course, but more modern ones like Fire Hydrant, Incident IO, Rootly, etc. Our customers are able to adopt the right tools for the job. And frankly, they always have more than one AI agent. So we also have this ability to collaborate with other AI agents. We can work with your infrastructure as code. We work with very complex topologies in this scenario. We had, 12 to 25 services, but our customers have a lot more. And then we work with all the backends that you need. So key takeaways, it's hard to do RCAs, period. It's even harder on-premise because of the lack of cloud APIs, the complexity, the different layers, the history of these systems that include sometimes mainframes, different, architectures that have been layered over the years. Hawkeye found the Terraform typo because it had access to the config using MCP. So we see a lot of value to MCP. We see our customers building MCP servers, vendors offering MCP servers. So you should really look at adopting MCP servers to bridge the gap for on-premise. We had 100% accuracy because of the context that we were able to uncover. This is what makes Newbird different. And then we have, a very secure solution that fits very well with the concerns of our on-premises customers. And then finally, you can have one agent that works for your on-prem VMware estate as well as your AWS, Azure, GCP estates with no change. So thank you very much for having me today. This was an honor to present to you, and I'd encourage you to attend a LinkedIn live session. You have a QR code here that you can scan, where my colleague Bennett is going to be presenting with the AWS team. So Kishore from AWS is going to present with Bennett on using Newbird Hawkeye with CloudWatch for agentic AI for AWS operations. So thank you very much and have a great rest of your day.
Thank you so much, Francois, for such an incredible thought leadership. I also want to thank everyone else for joining us today. This session, along with all of today's content, will be available on demand following the event. Our next session will begin at 12:40 p.m. Eastern Time, which is a keynote presentation titled Stages of AI Maturity in Finance. Please remain on the stage, and the next session will begin automatically. We look forward to seeing you there.